Hello, welcome to Millionlights. My name is Pratik Shah. I am an assistant professor in Dr. D.Y. Patel School of Engineering. In the previous module, we had seen some of the programming aspects. Now, in this module, we will see LCD, that is liquid crystal display. We will see what is LCD, how many pins it has, how can we use it, and what all things we can do with it. LCD. LCD stands for liquid crystal display. Here I have along with me a 16x2 LCD. That means this is capable of displaying 32 characters, symbols, alphabets, anything. Now here it is having 2 rows and 16 columns. Now this, for using this, we have got these 16 pins that you can see, and depending upon them we have got the naming for them, such as VCC, VSS. We will see all these things in the next part, in the next coming parts. But let us first understand what is the use of LCD and why should we learn it. Now the earlier display that we seen was 7-segment display. It was used to display numbers, that is 0 to 9. But if I want to display a symbol of dollar, if I want to display Z, it wasn't able, or I wasn't able to display it with the help of 7-segment. Hence I need something which can display characters, alphabets, symbols and all these things. That's why we have got this LCD. So this LCD is very cheap. It is less than 160, 150 rupees, around that we get this, and it can be used to do lot of interesting things. Now whenever you want to display any information to the user, suppose we are using ultrasonic sensor and we are measuring the distance, but in that case the distance was displayed on PC. Now every time it is not possible to connect our Arduino to PC and display the things on that. Suppose I am creating an embedded system and that embedded system is placed in the environment where it is measuring and it is displaying the details. Now I cannot use PC there. So I want some alternative, some display which is cheap and economical and it is simple to handle. So in those cases we use LCDs. Now one classic example of an embedded system where LCD was used is our coin operated phone boxes or PCUs. In that we entered 1 rupee coin, and at that time it displayed insert the coin. After that it will display how many seconds you have, or how many times, what is the duration till what you can talk. In the same way, in the weighing machines where we insert the coin, and in lot of places you will find lot of embedded systems where you want to give instruction to users. At that time LCD is used because it is cheap and simple. So today we'll explore it, we'll understand how to use it, how to display on it, and what all things are used in this, means what all pins are used for that. Okay, so first thing, as I said earlier, it is 16x2, that means it has got 2 rows and 16 columns, so I can display 32 things. Now what is the 32 things? It is alphabets, characters, symbols, numbers, anything. Anything that is mentioned or defined in ASCII can be displayed on it. Now for displaying these things on it, we need to do serial communication from our Arduino to this. So we have to learn that. We have to see what are the pins that are connected onto it and these all things. So first, now in this presentation we can see there are 16 pins and each and every pin's working is explained in here. The first pin is VSS. Now VSS is a ground pin. As you know, every electronic device requires a VCC, that is 5 volts, and a ground, that is supply and ground is necessary for its operation. So here first number pin is VSS, that is ground, and second number pin is VDD, that is positive or plus 5 voltage. Then we have third pin, that is VE. VE is used for adjusting the contrast. It is called as contrast voltage. It is used for adjusting the contrast. Now in this LCD we have got two types of controllings regarding display. One display is for the backlight. Now in this LCD we can have a backlight, that is LED will be glowing, so that it is good for visibility at night. So one display option is that. Second display option is based on the characters that we are printing. So we can adjust the contrast of those characters. So the darkness, that is the black or the color of that, can be adjusted. The darkness we can dark it or fade it depending upon our requirement. So for adjusting that we have to use pin number 3. Now how we can do it? We can do it with the help of potentiometer. When we'll do the circuit diagram, at that time we'll explore it further. Okay, so that was regarding pin number 3. Now pin number 4. Pin number 4 is register select. Now this pin is important because what are we going to do? We are going to send ASCII codes to the LCD and we are going to tell it to display onto it. It will display it perfectly alright, but at what location we have to display? That is on the first location, second location, first row, second row. That is what we have to say. So there are two types of instructions from Arduino to this LCD, or from any controller you can take. From any controller to Arduino, whenever you give two types of instructions. One is our commands and second one is data. So the data that you want to print is ASCII code 8-bit done, and the next thing is commands. Commands like you want to print on first row, second row, at which place, you want to blink the cursor or not, you want to scroll it on the left hand side or right hand side, you want to do clear the LCD. So there are a lot of commands that we need to give. So along with commands we also have to send the data. So to specify whether we are sending the data onto LCD or command onto LCD, we require to use register select mode. So if you want to send data or command, for specifying that we have got this register select pin. So with the help of that we can control, or we can tell LCD that we are sending data or we are sending command. Okay. Then the fifth pin is read write. That is, read write means what? You can either write the data onto LCD or you can read the data that is already printed on the LCD. Now in this case we are just going to write the data onto it. We are not going to read the data that is available on it. Therefore we are going to ground this pin. Then the sixth pin is enable. To enable LCD we will use the pin number 6. Then from pin number 7 to pin number 14, that is data 0 to data 7. Now these 8 pins are connected to your Arduino for transmitting data. The data is what? Character. One character means 8 bits, because of the we have ASCII code of 8 bit for each and every character, symbol, number. So everything is in ASCII. Therefore we require 8 bits that are to be connected from Arduino to this. Now these are from pin number 7 to pin number 14. Then just 2 pins are left, that is pin number 15 and 16. Pin number 15 and 16 are used for backlight. That is, either you want the LED to be glowing or not. So if you connect pin number 15, that is anode, to the positive terminal, and you connect cathode, that is pin number 16, to negative terminal, similar to LED, this will go, the black light will glow. Now when the black light is glowing, the advantage is that in the night also we can see the LCD. Okay. So two types of display adjustment, one is regarding backlight and another one is regarding contrast. So these are the 16 pins, just 16 pins are there and quite simple it is. So this is how the pin diagram is. Now we will see how we can connect it with Arduino and how the building of the circuit and programming is done. Let's see the LCD interfacing schematic diagram. Here we have to connect LCD with Arduino. For that, first of all we'll see which pins of LCD are connected to Arduino at which locations. First pin, as we know, is VSS, that is ground. So we are connecting it to the ground pin of the Arduino. Then second pin is VCC, and VCC is connected to 5 volts. This is important because if we do not provide VCC and ground, then it won't work, and this LCD will not display anything. It will not work properly. It will not work at all. Then the third pin is VO, that is contrast adjustment. So depending upon the voltage that we provide to it, the contrast is adjusted. So for adjusting it means what? We want to change the value of the voltage that is given to it. The best thing that we can do is we can connect it to the resistor, that is variable resistor, that is potentiometer. So we have got 3 terminals of potentiometer. First terminal is connected to 5 volts, third terminal is connected to ground, and the center terminal, that is the control shaft or the wiper, that is connected to VO. So we can adjust the value of potentiometer, and with the help of that we can adjust the contrast of the LCD display. Okay. Then fourth pin is register select. So it is used to tell LCD that whether I am sending a code or whether I am sending a data. Therefore, it is to be connected to Arduino pin number 12. From pin number 12, I will be giving instructions to Arduino, will be giving instructions from Arduino to LCD regarding the data which is code or our data, command or data. So we have to take care of that. Then fifth pin is read write. So as I already discussed, we have to connect it to ground because we are just writing the data onto LCD. Then the sixth pin is enable, that is connected to pin number 11 of Arduino. Then here there are two configurations in which you can use your LCD. So you can use your LCD in 8-bit data mode, that means you are connecting 8 pins from Arduino to LCD and you are transmitting one character at a single go, or else what we can do is we can use a 4-bit data mode in which 4 pins from Arduino are connected to LCD, and for sending one character we will have to send 2 times the data, that is 4 bit in the single go, that is LSB can be sent, then MSB can be sent in the second go. So for sending one character or one alphabet we have to send 2 times because we are connecting only 4 pins. The advantage of this configuration is it saves a lot of pins, that is it saves 50% of the pins that are connected from Arduino to LCD. So in this programming we are going to use 4-bit mode, and then last 2 pins, okay, and those 2 pins are from DB4 to DB7. So we are using the MSB, DB0 to DB3, that is the first 4 bits are skipped and the last 4 bits from LCD are connected to Arduino. The DB4 is connected to data pin 5 and similarly DB7 is connected to data pin 2. Okay, and finally just 2 pins are left, that is LED plus and LED minus, that is anode and cathode of our LCD, and that is to be connected to the VCC and ground so that we get the backlight. So this is the connection. It has got few of the connections and we also have potentiometer. Now what we'll do is we'll assemble the circuit, we'll build the circuit, and then we'll talk about the programming part. Now let's start building the circuit. For this we require these components. First one, we require Arduino board. It is required to connect to LCD. We require breadboard to make the connections. LCD, a potentiometer is used to adjust the contrast of the LCD. Jumper wires, we require a lot of jumper wires because there are a lot of connections. USB cable to connect Arduino with PC, and then a screwdriver. Screwdriver is used to change the value of the potentiometer, which will in turn change the contrast of the LCD. Okay, so first we start by placing LCD onto breadboard. Okay, so it easily goes inside the breadboard without any problem. Fine. Now let's start making the connections pin by pin. Okay, before that I'll take a black and a black and red colored cable because I want to create a VCC and ground rail, because there are a lot of VCC and ground connections which are required. So if you take red and black color, it is good to identify and we do not make any mistakes, and there will be a reduction in the chances of short circuit. Okay, so first I'll connect this VCC. Okay, I'll connect this VCC on the right hand side. So this right hand side rail complete is of VCC. 5 sections, 1, 2, 3, 4, 5. These 5 sections are of VCC. Then I'll connect ground, and ground I'll make on the left hand side. So 1, 2, 3, 4, 5. These 5 sections are of ground. Okay, so anywhere you want to provide 5 volts, you connect to this. Anywhere you want to connect ground, you connect this. So we have created VCC and ground points in our circuit. Okay, now let's start with one pin at a time. Now we take first pin of the LCD. First pin of the LCD is VSS, that is ground. So we have to connect it to the ground. Okay. Now the second pin is VSS, and VSS is connected to 5 volts. Fine. Now we'll make all the other connections. The third pin is VO, that is contrast adjustment. So for that we require this potentiometer. So what I'll do is I'll place this potentiometer on the breadboard. Place it properly so that it is firm and fixed properly. Okay. Now I have to make connections. First terminal, that is this terminal, goes to VCC 5 volts. The third terminal, this terminal, goes to ground. Then the center one, that is the middle one, it is the one that is going to pin number 3. So it goes to pin number 3 and pin number 3 is our contrast adjustment. So with the help of this screwdriver, we can place it here and we can adjust the contrast. Okay. Now let's connect pin number 4. Pin number 4 is register select and pin number 4 is connected to pin number 12 on Arduino. So this is 8, 9, 10, 11, 12. So pin number 4 is connected to pin number 12. So register select is connected. Now pin number 5 is read write and we have to connect it to ground. So I am connecting it to ground directly. Okay. Now pin number 6. Pin number 6 is enable and enable pin is connected to Arduino on pin number 11. So enable is connected to pin number 11 on Arduino. So there are two connections that we have made till now from Arduino to LCD. Those are pin number 12 and 11. Pin number 12 is register select and pin number 11 is enable. Okay. Then these 4 pins are skipped, that is 0, 1, 2 and 3. And then from D4 we are starting the connection further. So D4 is connected to pin number 5. So pin number 5 is here, 7, 6, 5. Yes. Okay, that is connected to pin number 5. Now D5 is connected to pin number 4. D6 is connected to pin number 3 and D7 is connected to pin number 2. So 4 pins from Arduino connected to 4 data pins here and 12 and 11 from Arduino is connected to register select and enable. So these are 6 pins that are connected from digital output pins, input output pins from Arduino to LCD, and rest all connections is regarding power supply, that is VCC, ground and all the things. Okay, now 2 more connections are remaining. Those 2 connections are about anode and cathode of LCD. They are used for backlight. So pin number 15 and 16 are left. Pin number 15 is connected to VCC and pin number 16 is connected to ground. Okay. So with this our connections are complete. So there are a lot of wirings, but if you see logically there is not much of the connections. 6 pins from Arduino come on to the 6 pins of LCD, then rest all things is nothing but VCC, ground, VSS, VDD and all these supply pins. Now with the help of this you can make a lot of things, such as you can make we have learned a lot of things earlier. We have seen ultrasonic sensor. So instead of displaying the value of ultrasonic sensor onto PC, you can display it on the LCD. You can display the value of LDR onto it. You can display commands or instructions that you want to give to other, you want to display messages. You can do lot of things. Now we'll see how exactly it is done. So this is the circuit. Now I'll connect it to the PC with the help of USB cable and then we'll talk about the programming part. Okay, So I have connected it. Now one more thing that you can see is the backlight is glowing. This is glowing because I have connected pin number 15 and 16 to VCC and ground. So no other commands have been given, so there is no character, no alphabet, nothing is displaying on it because I have not programmed it. But since I have just connected pin number 15 and 16 to VCC and ground, therefore the backlight is on. The backlight is very important because due to it we can see at night, else we won't be able to see what is printed on it. Now we'll see the programming part and then we'll dump the code on the Arduino and we'll see the output. Now we'll see the programming part. Here you can see the program is quite simple. It is just of 8 to 10 lines. Now the aim is to display hello world on this LCD. So we want to display hello world on this LCD. So we'll see the programming part. But before that I would like to tell you that we are just having 10 to 12 lines, and if you are using 8051 controller, Atmega controller, AVR controller or any other controller, for doing this you require at least 3 to 4 lines of codes. So the program of LCD is very long. It is having lot of instructions, commands and all these things. So remembering them, programming them is very difficult. That's why we are learning Arduino, because it makes these things very simple. So now we'll explore the code. First instruction is hash include liquid crystal.h. So we are including a header file. The name of that header file is liquid crystal.h. Fine. Then liquid crystal LCD 12115432. This is the next thing. Now what is liquid crystal LCD? Here we have first of all defined a library or included a library called as liquid crystal.h. After that we are making a constructor whose name is LCD. So when we make a constructor, at that time we are sending it some parameters. Now what are these? 12 11 5 4 3 2. 12 11, if you recall, 12 is register select, that was connected from LCD to Arduino. 11 is enable, so these two pins are given in the particular order. Then 5 4 3 2, these are the 4 pins that are connected from Arduino to the LCD. So these 6 pins are connected from LCD to Arduino, therefore we have to send them in a particular order. Therefore with the help of that, what will be in a position of using the functions or methods that are available with the help of this liquid crystal.h library. Okay, so this was initialization part. Then we have void setup. You can see that in void loop I am not writing anything. I don't want to do anything repeatedly. In void setup everything is done in detail. So the first instruction is lcd.begin 16,2. That means lcd.begin, as serial communication we started in the same way we are starting the communication with LCD, that we want to display LCD, therefore lcd.begin, and at that time we have to mention how many rows and columns we want to use. So I want to use full-fledged LCD, that is I want to use all the 16 columns and 2 rows. Therefore I am writing LCD 16 cross 2. You can write 16 cross 1, 16,1, then what will happen is only one row will be available. If you write 4,2, then 4 rows and 2 columns will be available for you. So depending upon your requirement, how much you want to display, you can set that. Now here I want to use the complete entire plane of LCD, therefore I am writing lcd.begin 16,2. Okay. Then second instruction is lcd.setCursor 00. So I am setting the cursor to the location 00. That means I am starting from the first row and the first column. If you want to display it on the second row and and first column, then you can do that. If you want to display it on the second column, first row, or whenever you want to display, you just have to write the location and it will display, it will start displaying from that location. Then lcd.print. Here the text that I want to display is written here. I want to display hello world. So I have written that inside lcd.print instruction, and it is written inside the inverted commas and the round brackets. So this is just 3 instructions that we are giving from Arduino to LCD, and this will display hello world onto the LCD. Now we'll upload this code, we'll see the results, and after that we'll see how we can change this code. Now we'll upload the code on the Arduino board. To save the time, I have already typed the code on the Arduino IDE. Now I'll upload that code. The code is getting uploaded. It is the same code that we have seen in the presentation. Okay, so now let's see the output. Now it is displaying hello world. It is displaying hello world, and now we can change the contrast of it with the help of the screwdriver. So if I reduce the resistance, it goes off. If I increase it, it is displaying, and if I increase it to a level, it goes completely black. So I have to adjust it optimally so it displays just fine. So this is how we use potentiometer to adjust it. Now I'll keep it and we'll make few of the experimentation based on which we'll change the output. Now here we are displaying hello world. So instead of that, I want to display few other things. I want to display here million lights. So first thing that I'll do is instead of displaying hello world here, I display million lights. So how can we do that? As we have discussed earlier, instead of writing in the lcd.print, instead of writing hello world, I'll simply replace it by million lights. So if I write this, I compile the code, I upload it, and it should work perfectly alright, and it should show million lights. So in this way, whatever instruction you want to give or whatever things you want to print, just set the cursor, set the position where you want to print, and after that you can use lcd.print instruction. lcd.print instruction can be used and you can print any data that you want to print. Just take care that the data is of 16 characters or 16 digits including the blank spaces, because if it exceeds, then only 16 digits or alphabets or symbols will be printed and rest all things will be skipped. So for that we have to scroll it to left and right. So we can do that also. We'll see that in the coming parts. So this is how you can display any text on the LCD with the help of lcd.print instruction and setting the cursor. Now we'll see the use of set cursor function. In the previous part, what we have done is we have displayed million lights on the first row and the first column. Now actually for LCD it takes it as 0 and 0, that is 0 row 0 column, that is what terminology it follows. So for us it is displaying from the first row and the first column. Now if you want to change the position of it, you want to display it from the second, or I can say the third row, that is you want to start to print it from third row to the end you want to go. Okay, so you want to follow that thing. So for that we'll have to change the set cursor function. I want to print it on the top part only, but it should not start from the first slot, it should start from the third slot. So it should start in the third column and on the first row. So for that I have to make few changes in the code. And what are those changes? Those changes are to change the value of set cursor. The set cursor, first instead of 0 0, I'll write 2 and 0. So that means the column is 2, that means the column it will print on the third part or the third column, and the row is same, so it will print on the first part only. So now after implementing, it's getting uploaded, and yes, you can see it has shifted by 2 places. So instead of printing it on the first part, it is printing from the third one, but still it is printing on the top part only. What I want to do is I want to print it at the bottom part. If you print it on the second column, then you have to make another change, that is you should write it as 1 instead of 0. Okay, so let's upload this code and check the output. It should come down. Yes, it's coming down. So lcd.setCursor is the function that is used to set the position from where you want to print the data. Now it has got 2 parameters that we want to send. First parameter is the column parameter and the second parameter is the row parameter. Column are these vertical lines and rows are these horizontal lines. So we have totally 2 rows and 16 columns. But if I write 1 1, that will not print on the first column and first, it will not print on the first column and first row. It will print on the second column and the second row, because its terminology starts from 0 0. So when I write lcd dot set cursor 0 0, it will start printing at the first location. If I write 1 1, it will start printing on the first row and the first column. So that is what we need to take care of. Then second thing is, here first lcd.set cursor, the first parameter that we are transmitting is regarding the columns. So it is not rows, it is columns. So I can say that lcd.set cursor 5 comma 1 or 5 comma 0, it is okay. That means it will start printing from the sixth slot. That is one thing that we need to take care of. So it is always columns and rows when we talk about LCD, and it starts from 0. If we keep this in mind, then we can print anything at any place on the LCD, just we have to calibrate it from 0. Hope you like the video. If you have any queries, you can find us on Facebook by the name Millionlights, or on Twitter. You can visit our website www.millionlights.org for more such interesting courses. Thank you.